So the previously discussed page fault processing assumed that there would be free frames available on the free frame list. Now the page fault handling must be modified to free up a frame if necessary as follows. Alright, so these are the page replacement or the basic page replacement. Okay, so this is an algorithm. So find the location on the desired disk, okay, or desired page on the disk. Find a free frame. If there is a free frame, then we're going to use it. If there is no free frame, so we are going to apply the page replacement algorithm to select the victim. So when you say victim frame, this is the frame or this is the page that we need to replace. Okay, so write the victim frame to the disk if dirty. So we're talking about 30-bit, okay, or the modified bit. So bring the desired page into the newly free frame, update the page and frame tables. So continue the process by restarting the instruction that caused the drop. Okay. So this can be alleviated somewhat by assigning a modify or dirty bit, okay, to each page, indicating whether or not it has been changed since it was last loaded from the disk. Alright, so if the frame or if the dirty bit has not been set, then the page is unchanged and does not need to be written out to disk. Otherwise, the page is or the page write is required. Right? So it should also come as no surprise that many page replacement strategies specifically look for pages that do not have their dirty bit set. So that would be preferentially select clean pages as a victim page. Okay? So it should also be obvious that unmodifiable code pages never get their dirty bits set. Alright? Okay, so page and frame replacement algorithms. So we have this two major requirements to implement a successful demand paging system. We must develop a free or a frame allocation algorithm. Okay, so determines how many frames to give each process and which frames to replace, and a page replacement algorithm. Okay, so wants the lowest page fault on both first access and reaccess. So the former centers around how many frames are allocated to each process, and the later deals with how to select a page replacement when there are no free frames available. So that's where we apply the page replacement algorithm. Alright, so the overall goal in selecting and tuning these algorithms is to generate the fewest number of overall page faults. So the lower or the algorithm that would give us the lowest page fault would be considered the optimum algorithm. Right? So because disk access is so slow relative to memory access, even slight improvements to these algorithms can yield large improvements in overall system performance. Okay? So next, we have this relation of the number of frames with the number of page faults. Okay? So this graph indicates that as the number of frame increases, the number of page fault should decreases. All right. So as the number of frame increases, the number of page faults should be decreases. All right.